Let's do the graphing polynomial functions. In this problem, we are asked to graph p of x is equal to x raised to 5 plus x raised to 4 minus 7x cubed minus x squared plus 6x. The factored form of the given polynomial function is p of x is equal to x times the quantity of x plus 1 times the quantity of x minus 1 times the quantity of x minus 2 times the quantity of x plus 3. The next thing to do in graphing polynomial functions is to identify the zeros of the given polynomial functions given the factors. So with x, the zero is 0. With x plus 1, the 0 is negative 1. With x minus 1, the 0 is 1. With x minus 2, the 0 is 2. And with x plus 3, the 0 is negative 3. After identifying the zeros of the given polynomial function, let's make a table of values, putting all the zeros from negative to positive, putting spaces in between. And since these are the zeros of the given polynomial functions, it's automatic that their p of x, by using the factor theorem, the values will always be 0. And that's the reason why they are called the zeros of the given polynomial functions. Next, after which, let's put values for x in between each zero. So we have here negative 4, negative 2, negative 0 0.5, 0 0.5, 1.5, and 3. The next thing to do is to substitute the values of x in our given polynomial function. So the p of negative 4, by substituting the value of x in our given polynomial function, it will result to negative 360. For p of negative 2, after substituting, the value will be 24. For p of negative 0 0.5, the value will be negative 2.3. For p of 0 0.5, the value will be 1.97 or around 2. For p of 1.5, the value will be negative 4.2. And finally, for p of 3, the value will be 144. So let's just fill in our table with the values that we got. So for p of negative 2, for negative 2, it's 24. For negative 0 0.5, it's negative 2.3. For p of 0 0.5, it's 1.92. For p of 1.5, it's negative 4.2. And for p of 3, it's 144. Now, it's time for us to graph our function. First is, let's graph the given zeros of our polynomial function. Simply locate the positions of these coordinates, negative 3, 0, negative 1, 0, 0, 0, 1, 0, and 2, 0 in our Cartesian plane. So negative 3, 0 is here. Negative 1, 0 is here. 0, 0 is here. 1, 0 is at this point. And finally, 2, 0 is this point. Since we have a quintic function and having 5 as the degree of our polynomial function, subtracting it by 1, we will have 4. So expect that there will be 4 turns in our graph. Since it is positive, our leading term is positive. Expect that the movement will be like this. First turn, second turn, third turn, fourth turn, and it moves continuously. So expect that there will be 4 turns in our graph. So that will be 1, 2, 3, and 4 turns. So by looking at our graph, at our Cartesian, at our table of values, let's identify the movement of our graph. For negative 4, 360, it's somewhere there down below. So the movement will be from this point, passing through 3, 0. And then for negative 2, negative 2, 24. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 at this point. So our movement will continue to this point. And then the next point will be negative 1, 0 from 2, negative 2, 24. It will go back down to negative 1, 0. And then negative 0.5 to negative 2.3. Negative 1, negative 2.3, somewhere here. So we'll continue there, passing through this turn. After that, it will go back to 0, 0. Next is 0.5 to 1.92. It's somewhere here. Continue the point, the movement of the graph. And then 1, 0, going back to 1, 0. And then 1.5 to negative 4.2. 1.5 to negative 4.2. 1, 2, 3, 4.2, somewhere here. Moving it down there. And finally, 2, 0, going back to this point. And for the 3, it moves continuously going there. That's it. And that's how the graph of our given polynomial function looks like. So this represents the graph of p of x is equal to x raised to 5 plus x raised to 4 minus 7x cubed minus x squared plus 6x. That's it.